Hello everybody, welcome back to the second to last workshop in the Worldcoin Educate series. I'm sure you're all really disappointed that the series will be coming to an end soon. But today we have dcbuilder back again to talk about the Worldchain this time.
So today, as Rebecca mentioned, I'll be talking about the Worldchain and the OPStack. Let's get right into it. So this is the almost the last one, right? Like we only have two more to go out of the Educate series. And so, what is Worldchain, right? So I borrowed a couple slides from the introduction to WorldCoin presentation because it has some really good ones. So what Worldchain is, it's a blockchain, a scalability solution for WorldCoin that essentially allows or prioritizes humans to have priority transaction space and also free gas allowances. And the way that is implemented, we'll get into a bit later. But the main values of Worldchain is that it's open source, it's permissionless, it's secured by Ethereum. It directly tightly couples WorldID, our proof of personhood protocol, into the chain itself, so that you're able to do things like the priority block space and free gas allowance, because you have this notion of what a human is, right? So you can do proof of personhood on the on-chain level, therefore you can get allowances for humans or priority block space, meaning that you get prioritized in the transaction pool with other transactions, right? So unique humans get on top priority. And not only that, but you can use WorldID natively, just like you did on Optimism, for example. And we're going to launch it with 10+ million users from the World app. So just to, so right now, the Worldchain is in developer preview. So what that means is that any developer can currently like fill out a type form, like just a form, and request access to Worldchain. The Worldchain is technically live, however, it's not publicly available just yet. It's mostly because we're just setting the stage so that all the infrastructure that people are accustomed to, things like block explorers, different dApps, different infrastructure for tooling and testing, things like smart contract wallets or testing tools like Tenderly and a bunch of others. So essentially, that's like what the developer preview means. And all sorts of other ecosystem builders that have partnered with us are also deploying there. And as I mentioned, we're also migrating the World app. This is something I migrated that I mentioned before. So currently, World app is on Optimism Mainnet. And now we're going to be migrating over to Worldchain. So to mention a little bit, again, or reiterate for those who maybe weren't here for the first presentations. So the World app is this sort of center place for the Worldcoin ecosystem. It's the main way of interacting with Worldcoin for most people, right? So what it allows you to do is it allows you to hold crypto. It allows you to use WorldID, and it allows you to essentially interface with the Worldcoin ecosystem. So currently, all of the Worldcoin users are on Optimism Mainnet. Every single user has a safe smart account, and all of those things need to be migrated over. And so this is some of the stats that I mentioned before at the very top. This is some like old stats from June 2024 or up to June 2024. So this is where the 10 million plus user benchmark comes from. And it's currently is like almost 6.7 million verified users by the orb, and a little bit over 13 million or somewhere over 13 million World app downloads across iOS and Android. So the things that actually live technically, right? Like I mentioned this briefly, this is another slide from the introduction, just to reiterate. The World app has the self-custody wallet, which is a safe smart account. And you're able to use the things you know and love, and some new features like passkeys and account abstraction that we're going to be part of World app soon. So like I mentioned also before, this is sort of like our quick journey of how we got here. So in 2021, we built this custom scaling solution called Hubble. We took over a project that was built by the Ethereum Foundation, and we took it to production. However, we knew that people wanted to have a general purpose EVM to do smart contracts and more interesting things than just payments, like sending tokens back and forth. So we launched on Polygon POS. Then after a year, we migrated over to Optimism Mainnet. So that was last July with launch, like when we launched WorldCoin officially. And now, over a year later, we're migrating over to Worldchain. So some of the major reasons why we are migrating to Worldchain is, for one, the L2 ecosystem. When we first joined Optimism, it was still nascent. It still is to this day. So there's a lot of infrastructure that we had to build ourselves. The costs were quite high throughout time, so we contributed to Ethereum efforts like 4844, EIP 4844. For those who don't know, it's an Ethereum improvement proposal that was passed on Ethereum a while ago, a few months ago. I think it was like last year, sometime around October, if I'm not mistaken. I'd have to check. But essentially, this change allowed scalability solutions like L2s that post data to Ethereum to post data to Ethereum for a much cheaper price. And this, in turn, lowered the prices of L2s across the Ethereum. Because you're allowed to post more data to Ethereum, and therefore there is less competition for gas. And so you're able to fit more transactions. Another thing that we did is like a lot of custom compression, so that you minimize the amount of data you put on chain, but still have the same functionality. And the main thing that we realized is that like L2 execution gas. So for those who don't know, the EVM, or the Ethereum virtual machine, is this layer on Ethereum that holds a database and allows you to programmatically change this database. And so the way that it works is that there's programming languages that allow you to build programs on top of the Ethereum virtual machine. You may have heard of programming languages like Solidity or Viper, or maybe some others that are more niche. And what these allow you to do is to build applications that, for example, do things like decentralized finance, right? Like Uniswap is written in Solidity, right? Like Yearn maybe is written in Viper. There's a bunch of different applications, and all those are written as smart contracts. And so each operation within the EVM, so at the very end of the smart contract, if you compile it to the EVM, you have just basic instructions of the virtual machine. And each instruction in this virtual machine has a price associated with it, which is called gas. And there's only a finite amount of gas per block that every block can have. And each transaction that does any EVM operations essentially costs gas. And so if you have a limited amount of gas, you can only do a limited amount of transactions per block. And this is the fundamental bottleneck for execution. It used to be data, meaning as like posting data to Ethereum, and that was thoroughly solved with 4844. But now the next bottleneck is execution gas. And so migrating over to L2s is also like one of the motivations for that, is because L2s are on a trajectory to keep increasing the target gas that they can consume per block, thus scaling even further. Hence, we migrate over to Optimism Mainnet, and now over to Worldchain, partially for those reasons. So I keep mentioning this thing like Optimism, OPStack. Maybe you know what it is, maybe you don't, but this is what we're here to learn about. So OPStack is it's a scalability solution, right? It's a scalability solution that allows people to build rollups and other types of L2s. And essentially, it's an open source piece of software, right, or groups of software that is modular, meaning that there's some abstractions over how it works that allow you to change different parts and plug them however you want. You know, you can modify specific parts of the configuration of the code to allow you to do different things in slightly different ways. And so that what it means by being modular. For example, you can choose to settle on Ethereum, but you can choose to settle somewhere else. You can choose to settle your data, for example, on some other solution like Celestia or Eigenlayer or something else. Its fundamental purpose is to scale, in this case, Ethereum. And the way it does that is that it's a separate network where you're doing transactions on it. And the way that it achieves security or transactional security is by posting its data to Ethereum in a compressed manner. And anyone can sort of challenge the state transitions, as they're called. Essentially, it's like whenever you're changing the state of the database, right? So I have a block, the current state of the block, let's say that my balance is like 0.1 ETH. If someone sends me 0.1 ETH in the next block, then that's a state transition, right? Like my state is transitioning from balance of 0.1 ETH to 0.2 ETH, and therefore I need to like do that, right? So like I'm executing an EVM transaction that changes my balance, and this is sort of like how the Ethereum works, or any L2 works, or any blockchain really. And so the way that optimism works is using these things called fault proofs, and essentially it's an optimistic approach. So maybe you've heard the term optimistic rollup before. So an optimistic rollup is essentially a scalability solution that allows people to just pose these transactions to this separate network, and the separate network will execute them. And whenever you want to settle back to Ethereum, what you do is that you have this 7-day period that allows people to challenge the state transition's correctness. And so if there's an incorrect state transition, people can challenge it using this fault-proof game. The way that that is implemented is fairly complex, but it works. There's several implementations live, and essentially you're able to challenge or dispute any incorrect state transition. Let me just quickly check if there's questions, or at least pull them up over here so that I have them. All right, so far so good. I think maybe one question. When will the Worldchain start approximately? So I cannot share details just yet. It was a little bit delayed since summer 2024 is already here. There is mostly some third-party integrations that made that happen, because it's not just on us, right? Like we need a lot of partners to deploy, so we're able to migrate. So Worldchain technically was launched in summer, but it's not publicly available. So yeah, it's still a little bit more to go, Rainy. Yeah. So essentially with these fault proofs, what you're able to do is you're able to prove that the state transitions on Optimism or on the OPStack were correct. So there's no incorrect ones. And if there's an incorrect one, someone can challenge. The person who proposed those state transitions gets penalized, that gets their stake and gets their economic stake slashed through this fault proof mechanism, and you revert back to the state that was valid. And so maybe you've also heard the term validity rollup. So last time I talked about zero-knowledge cryptography. So zero-knowledge cryptography is the sort of technique or cryptographic machinery that is used to build this notion of ZK rollups or validity rollups, where you create cryptographic proofs of the execution of the state transition, right? So you can have like a ZK EVM, for example, like ZK Sync or Scroll or Linea. Maybe you've heard those names before. And so those ZK EVMs are technically not ZK EVMs. Like I mentioned before, there's a nuance to the term zero knowledge where you're hiding stuff. In this case, zero knowledge rollups, the ways that the term is used usually is misused because it's a validity rollup. There's nothing being hidden. The state transition is public to the verifier. And so essentially these proving mechanisms allow you to execute something off-chain in this separate network, and allow you to post it back onto Ethereum and sort of have the same security that Ethereum has, with some added assumptions like the security of the fault-proof program and the security of the ZK or the validity rollup, the cryptography, right? But essentially you're able to scale by having a separate network where you're executing lots of these transactions on just one computer. Then that one computer like batches those and compresses those transactions as much as possible. So you're reducing the size of those transactions that you're posting back to the Ethereum L1. And then once they go through the fault-proof program or like the fault-proof dispute mechanism or the ZK or the validity rollup mechanism for proving these transactions were correct, then you can finally settle on Ethereum. And so the OPStack is one such tool chain. There's several others built by other competing solutions, like ZK Sync has the ZK stack or the Hyperchain. There's a few others, like Starknet has one based on Madara. There is Arbitrum has Orbit. I believe there's a few others that are out there that build on different tool chains. And so Optimism is one such of those. And so what Optimism includes, we're going to get to some of the meat here, is essentially an implementation for these things that I list here. So data availability, a sequencer, duration pipeline, an indexer, an execution environment, a settlement set of rules, a fault-proof program, and a governance mechanism. So if we break those down into its individual constituents, so when I've been mentioning like you're posting data to the L1, so this data availability is mostly only used so that you're able to challenge the state in the fault-proof program, right? So when I'm posting data to Ethereum and I want to settle on Ethereum, the thing that I'm settling is essentially the current state of the Optimism L2 or rollup onto Ethereum. And so I need to post this data onto Ethereum so that people can challenge it publicly in a permissionless way, right? If people want to challenge any part of the computation, then they can use this. So Brian has a good question. How does OPStack enhance scalability? So I mentioned that since now you have a separate network that is able to execute these transactions, you only need one computer to propose a new block. Nobody needs to validate it. You just post it optimistically onto Ethereum, and then you allow everybody else a 7-day window to challenge that state transition, to challenge that change in the computation of the database, right? So if anybody can challenge the computation that happens and the changes that happen to the database, then you can fairly prove that these things happened correctly, and then you can settle. So since you're settling a compressed amount of data and you're only settling, like you're only having to challenge one computer computing, this makes it a lot cheaper to actually do that computation as opposed to having the entire Ethereum blockchain, every single node work in unison to essentially verify a block. So the way that Ethereum works, or any blockchain works, or most blockchains work, is that there is this consensus algorithm where multiple computers on the network, they agree on the current next block, they elect a leader, the leader proposes a new block, and that block essentially gets re-executed by everybody else in the network. And then after everybody else re-executes that block, only then will they consider that block valid. So this is very, very cumbersome because there's like maybe like tens of thousands or hundreds of thousands of nodes on the network. So if every single one of them has to re-execute that block, maybe in like a 12-second window, it's a lot of wasted work. So it makes it expensive. So rollups or L2s and other scalability solutions, what they do is that they minimize this burden of distributed systems, that instead of having multiple computers executing the same thing, you only have one, and you allow them to either prove the validity of that computation using cryptography, like validity proofs, like SNARKs, STARKs, or ZK proofs, and or using optimistic mechanisms like fault proofs, where you allow people to challenge, and then you have this bisection game where you're like changing the state every single step of the execution trace, and you're checking whether the execution trace was valid in a public dispute game within a smart contract. So essentially, that's how it scales, right? You're able to only do the computation once and have a proving mechanism back to the L1 that this was correct. So you don't have to re-execute everything for every computer. You only have to execute it once, and then everybody else can verify. And if anybody finds something wrong, then they can prove it, and then everything reverts back to being correct. Or in the case of validity proofs, you can settle as fast as you create a cryptographic proof that whatever you did was correct. Okay. So next up, so I mentioned data availability, right? It's essentially the concept of settling data onto Ethereum from the scalability solution. And you can also settle that data elsewhere. It doesn't have to be Ethereum. OPStack is modular, right? As I mentioned before. So you can choose to settle on a different network like Celestia or EigenLayer, EigenDA, or Avail. There's a bunch of different solutions that allow you to settle on different places. And the way that that is priced is that there's a different economic security that is associated with the data being posted somewhere. Ethereum is the most secure programmable network that we have because there's about like $20 billion worth of Ethereum staked. And so that is the economic security of the Ethereum network. For other networks, there's less economic security, but maybe you can put more data on them, or maybe you have some cool cryptographic techniques, like you can do some nice things like data availability proofs and stuff. And there's a long roadmap of things that Ethereum is planning so that you're able to post more data and you have better properties. There's this thing called dank sharding and peer DAS. There's a lot of changes to Ethereum that are going to happen for this to be better as well, and to the other networks as well. So another thing is the sequencer. So the sequencer is essentially the thing that takes in transactions, orders them, proposes a block, and then that block gets executed by an executor in this case, right? So a sequencer is this important piece of infrastructure that essentially takes in all the transactions, orders in a block. They're essentially the proposer in this case. So currently, most sequencers are centralized in L2s because they're controlled by the teams that build the rollup in most cases. However, since you have this proving mechanism, you can trust the sequencer to output correct state because you can always challenge them, at least if they're deployed with a fault-proof program live or with a valid validity-proof mechanism. Then there's the derivation pipeline. So the way that rollups work is that once you post this data onto L1, anybody should be able to reconstruct the current state of the L2 from L1 state. And this is the so-called derivation pipeline. And so you can go through every single state transition over the place where you're settling your transactions, and you should be able to reconstruct the current state of Optimism in this case, or any other OPStack network. So this is called the derivation pipeline, or derivation for short. You have an indexer. So indexer is something that like indexes the data that is on the blockchain so that you can serve it through requests. So this is essentially indexing like an EVM database. So this is also part of the OPStack. There is an execution client. So this is the thing that actually does the EVM state transitions and computes the change of the data over the database. And there's settlement, in this case, for Optimism mainnet, which we're currently on, and Worldchain as well. In the future, it's Ethereum. So you're settling this state on Ethereum. Not only are we using Ethereum for data availability, but we're also using it for settlement. So whenever you're, for example, depositing onto an OPStack network, you're depositing through Ethereum in our case. All right. No questions so far. Great. And then, so once you settle, you're essentially finalized. You cannot revert the state after you've settled. Essentially means like it's equivalent to finality, right? On Ethereum, finality happens after 2 epochs. So you have 32 slots, essentially. So it's like 12 times 32. I always forget. I think it's like 12 minutes. 12 times 32. So 384 seconds. Is it that? It doesn't sound right. 32 times. Anyway, 64 times 12. Okay, yeah, it sounds about right. 786 seconds. 2 minutes. Yeah, it's about 12 minutes on Ethereum to finalize a block. So on Optimism or any OPStack network is like once you settle on the state on Ethereum, then it takes another 12 minutes for the state to be final. It's irrevertible. It's impossible for that state to ever change in the future. And then fault proofs, what I mentioned is this sort of program that allows you to prove that something was incorrectly executed on the scalability solution. So this is the thing that allows you to actually build the scalability solution in the future, in the first place. And then a governance set of smart contracts that allow you to do different upgrades to the network, right? So for example, Optimism currently can be upgraded by the Security Council of OP Labs and some other entities like Optimism Foundation and a few other external contributors. And so a governance essentially means is that there are some parties that are allowed to sort of do an upgrade to the network, right? So like if there's a new change in the execution pipeline, so let's say that there's a hard fork on Ethereum which changes the EVM, then that hard fork also happens on Optimism a bit later maybe. And so a governance mechanism is the thing that allows that change to happen because you're upgrading some smart contracts or you're changing some configuration or doing something along those lines. So for those who are curious, there's this GitHub repo. So if you go to github.com/ethereum-optimism/optimism, I have it opened over here. You can find the entire code for everything that relates to the OPStack. And so there's even like good documentation. Optimism itself has a great documentation over here. So you can, if you're ever curious about the technicalities of it, you want to watch more videos or read about like where everything is, right? We have things like the Optimism Challenger, which controls the dispute game agent for the fault-proof program. There's the actual fault-proof program implementation. There's an alternative one as well. There's the proposer. There's Bedrock, right? So there's the smart contracts for it. For like how Optimism actually works. There's a lot of technicalities for this, and a really like detailed documentation for how everything works on the technical level. So this is what it actually is, right? So this is what we mean. It's open source, meaning that anybody can download this. It's public. And another part of open source is that it's like licensed under a permissive license. So I believe that they use the MIT license, correct? Right? So like it's licensed under MIT. So it means that you can use it for free. As long as you credit correctly, you can use it for free for commercial use cases and everything else. So this is something that is very appealing because third parties that are building scalability solutions, they don't want to, for example, think of like paying someone for a license for something. They want to be part of this open source ecosystem and contribute to open source goods, public goods. And so this is why OPStack, we chose OPStack for Worldchain, right? Like it has all of these great properties. It is scalable, performance, secure. It has a lot of great technical architecture. It's extremely well implemented, very well audited, thorough, a lot of smart people working on it from the community outside of Optimism, a lot of third-party contributors, including ourselves and many other people like Coinbase with Base and a few other teams. So some of the interesting things, okay, some good questions I see on the chat. What are the limitations of fault proofs and how does it differ from validity proofs? Great question. So fault proofs, the biggest difference is that, well, you have this dispute period of 7 days for settlement. So this is like part of the worst user experience of it all, is that in order for you to withdraw from an OPStack network that is regularly configured with fault proofs and everything, you have to wait 7 days to withdraw from the smart contract of Optimism on the L1. Right, so the way that it works is that you lock funds on a smart contract on Ethereum, and then you mint, or the L2 mints your equivalent balance on the same address on Optimism, and then you're able to spend that balance on the L2. And then after you finish doing your thing that you wanted to do in Optimism, you can withdraw back to Ethereum using the bridge, but it takes 7 days for this dispute period to finish. And then once the state settles, you can withdraw against that state. Validity proofs, the way that they differ is that when someone just does a state transition on, let's say, ZK Sync, and someone posts a proof of that state transition being correct to the L1 smart contract, then it updates the state root of the tree of the state of the L2 that you can withdraw against. So finality or settlement is much quicker. So you can have almost seamless bridging from and to the L2, as opposed to with Optimism, where you can bridge immediately, but bridging back takes this 7-day period for the withdraw, for the dispute game period of the fault proof to finish for that specific transaction or state transition. So that's like the biggest difference from a user's point of view. The technical differences are extreme, right? Like one uses cryptography, the other uses cryptoeconomic mechanism design for you to challenge state. So yeah, that's the biggest change. What will be the minimum deposit? I believe that on OPStack you can just deposit as little as you want, really. You can deposit a Gwei if you want to, I think, as far as I understand. What is the Optimism Superchain? I see all over X. I'll get into that. That's like my next slide after this one. Are these apps going to charge for withdrawal? No, OPStack is not an app. It's just a piece of technical architecture. It's just some tech. It's a scalability solution. You can deposit to and from Optimism with no like added charge. The only thing that you're going to pay for that is the Ethereum L1 transaction, if you're depositing into an OPStack L2, or if you're withdrawing from it. It's just the transaction, so you're paying for that transaction to be executed. For Worldchain, however, and the World app, we handle all that for you. The user will just have a pop-up, just clicks, migrate, whatever, they'll migrate over, that's it. They don't have to think about paying for anything because we subsidize all the transactions on Optimism mainnet for World app users nonetheless, because we have WorldID, right? Since every user that we have is WorldID verified, we can afford subsidizing transactions for them because we know they are a unique user verified by the org. And also Worldchain will be subsidized for other users that are WorldID verified, and you can have this transaction priority as well. So this is the benefits of WorldID and tightly coupling them to something like an OPStack network, in this case, Worldchain. Cool. So now that is out of the way, let me just check time, 28 minutes left, great. So what is the future of the Optimism stack or the OPStack? So the OPStack has a lot of components, right? Like I mentioned before, There's this data availability, sequencer, derivation, indexer, fault proofs. There's a lot of moving pieces, a lot of technical stuff. Some of it is not technical, some of it is more like governance things. But what is the future of it? So currently, the main things that are being worked on are interoperability. So the main benefit of using a shared technology stack is that you can create different interoperability mechanisms between the networks so that they feel more seamless. Maybe you've noticed that now that there's like 7 or 8 different scalability solutions, like Scroll, Starknet, Arbitrum, Optimism, Linea, all of these others you see on L2Beat, you see that there's a lot of these networks, and the same app that is on Ethereum is not on all of these apps, not on all of these L2s anymore. Right, so you have to redeploy the same application to like 20 different networks. You have to replicate infrastructure, all the block explorers, testing tools, APIs, indexers, all of these and like critical pieces of infrastructure need to be replicated for every single one of these networks, and that is extremely, extremely painful. And it's very costly, right? And for an application developer, now you have to have this overhead of like, what network do I deploy on? How do I bridge my funds to this network so that I can use the apps on this network? So a lot of the current problems of scalability solutions that in the way that Ethereum is scaling is that you have fractured state and you have fractured ecosystems by turn, and so they're not interoperable. So one of the key focus for a lot of these scalability solutions now is making interoperability a core part of the thing. And so this is what currently OPStack is working on within OPStack network. So they're making every single OPStack network, so any network that is deployed with the code that I showed you earlier will be interoperable. And currently the timelines are by the end of the year, more or less, for that to hit production. It might be delayed because there's always like unforeseen things that can delay things, but currently the current estimates that I've heard at conferences and whatnot is like end of the year. And what this would mean for you or for any OPStack user is that you have seamless bridging from in and out any OPStack network. So let's say that I am a user on Worldchain, I have my World app, but maybe I want to go to like Base to interact with some social application, and maybe I want to go to OP Mainnet to interact with some DeFi app or whatever. So that sort of ordeal will be much simpler and native to the experience of the OPStack, as opposed to having to have third-party solutions to bridge and think of bridging and whatever. For the average user, it's too complex, and the user experience is horrible for most people, unless you're very technically savvy or a power user of on-chain applications. So there's that. Another one is decentralized fault proofs and multi-provers. So a fault proof is this program that I mentioned where people can challenge the state. The way that it's worked for Optimism so far, with some very minor exclusions or differences, is that the only person who could run, or the only group of people who could run this fault proof program was OP Labs itself, until a few months ago, where they decentralized the fault proof program. So anybody can run this fault proof program and submit challenges to the L1. However, recently there is a vulnerability discovered like 2 months ago or so, or 1 month ago. So they took it off again. So now only them can challenge the state and propose the state. And so the next immediate thing is to turn it back on once they remediate the security vulnerabilities that were found. And so once you remediate those changes, you can have the centralized fault proofs again. And that's sort of like the way things should be. Something that I can touch upon maybe towards the end, or maybe in the next lecture, since we have a very open-ended lecture towards the end, the future of Worldcoin tech. I can also chat a bit more about how that works if you're curious. But essentially, there's this different categorization of, let me actually find that out, L2Beat stages. So if I quickly search for this, there's this concept of decentralization stages that was created by one team called the L2Beat team. So I recommend you all read this. I'll just post it in the chat really quickly. But essentially, there's different measures of how decentralized a L2 can be. And it's mostly measured by their fault-proof mechanism, by their settlement, by their governance, and a few other metrics. And the more decentralized they are, the better the stage, right? So right now, optimism is what you would consider a stage 1 rollup. After you have decentralized fault proofs and you cannot challenge settlement and a few other things, it would become a stage 2 rollup. And then stage 3 is completely decentralized, right? Like there's no way that they can propose incorrect state or anybody can challenge it. There's multiple proposers of the state and a few other things. I'll leave it to you to read the article I just posted if you're curious about that. So yeah, so another thing that they're working on is a multi-prover. So a multi-prover means that instead of just having one implementation of the fault-proof program, you have multiple, right? So currently, the technicality of it, the way that it works is that you're doing emulation inside of this virtual machine that is implemented inside of a smart contract. It's very technically cumbersome of how to implement the fault-proof mechanism, but there's currently one implementation over this computational target that people are using, but now they're implementing for another one as well. So you have a different stack built in a different programming language with a different set of tools to implement the same thing. So they have redundancy. If there's a bug with one, but maybe not a bug with the other, the network is not compromised. You still have the security of like a quorum of these different implementations, right? So instead of being like only one, you maybe have like a 2 out of 3 threshold. So if 2 out of 3 malfunction, then there is a problem. But if one malfunctions, nothing happens. And the likelihood that more of them malfunction at the same time is radically lower than if just one malfunctions. So that's like multi-provers. That's like another change. Adopting L1 changes. So this is like if L1, like Ethereum L1, the EVM changes, then OPStack will reflect those changes so that everything is the same. They target EVM compatibility and equivalence so that building an application on the OPStack is the same as building an application on Ethereum from a developer's point of view. And I mentioned stage 2. So this is just like decentralizing even further. One cool thing that I find really exciting is ZK-ifying the OPStack. So the OPStack is currently using fault proofs, as I mentioned. But you can also, since it's modular, you can change the way that you validate state transitions and turn them away from using fault proofs to using validity proofs instead. So you can use something like maybe like the ZK stack from ZK sync maybe and mirror that and use it, for example, for optimism to prove that. The actual nuance of how that would work is quite complex, but there's already proposals from different teams to how to ZK-ify the EVM. There's proposals from teams like Succinct or proposals from teams like RISC-0. So I recommend you Google things like Zeph from RISC-0, or there's the SP1 OPStack or SP1 Optimism. Yeah. So if you search this is from the team called Succinct. And then there's a bunch of proposals from teams like Mina, ZK, fault-proof program, and a bunch of other teams that are building proposals to ZK-ify different parts of the Optimism stack or the OPStack. So that's what I mean by that. Essentially, instead of using fault proofs, you can migrate over to use validity proofs and get all the benefits of cryptography and validity proofs there. While still using the OPStack, really, you're just swapping one part of the entire thing. And that's the beauty of the OPStack. It's modular. You can swap things in and out, like settlement, like finality, like execution, the duration pipeline or the fault-proof program for a validity-proof program. You can change these things as you go because they're modular. Cool. Decentralized sequencing. So this essentially means that Optimism is not the only party. OP Labs is not the only party that is able to propose a new block or sequence a block, but anybody will be able to as long as they like run the sequencer and maybe they stake some whatever and they're able to propose blocks. That gets into some cumbersome edge cases because now you have things like MEV on the network, which is a hard problem in and of itself. If you're curious about that, I recommend you watch some videos about MEV or search online. And then the biggest one, I think that, or at least the biggest one that concerns Worldcoin and Worldchain is the GigaGas roadmap. So GigaGas means like a billion gas. And what gas is this unit of count of the EVM, right? So when you're doing transactions on the EVM, you're limited by the amount of transactions you can do there, because there's a finite amount of gas you can execute per block. And in the case of the EVM currently on Ethereum, it's 15 million gas per block. Every block is every 12 seconds. Maximum you can do in one block is 30 million when there's periods of congestion, using this mechanism called EIP 1559, for those who are curious. So essentially, if you divide 30 million gas by 12, you have like somewhere about like 3 million gas per second. So you don't really have that much you can do when it comes to gas, right? Like 3 million gas as opposed to 1 billion gas is a 333x in transactions that you could do if you're able to scale to that sort of scale. And so I also opened this link, I believe. So this is like one article from Paradigm, which is a VC fund that also does a lot of engineering. Maybe if this loads. I think my Wi-Fi is not working very well. I'll just post the link, hopefully, over here for those who are curious. I need to copy it over here and post it in the chat. Cool. So that link should show you like what the roadmap is for some of the execution clients on Ethereum. So essentially, there's a roadmap to scale the OPStack and all the different architectures of the execution layer for Optimism to allow you to do more transactions within an OPStack network by scaling further. Another one that we care about at WorldCoin is rustifying the OPStack. So most of the tool chains in the OPStack are written in this language called Golang, which was done by Google, created by Google a little bit over 10 years ago. And Rust is this other really popular programming language that essentially WorldCoin uses everywhere, and a lot of teams really like for a lot of different reasons. And so a lot of people are writing the same parts of the tech stack on the OPStack in Rust, as opposed to Golang. So this is another community effort that we care about. So I have 15 minutes, so I'll try to be quick. So the Superchain, this is a question that was brought up by Riddick. So you mentioned that is an unrelated question, but it's very much a related question. It's like part of the core of what the OPStack is and what it means. I should have probably named this a presentation: Worldchain, OPStack, and then the Superchain, right? Or like it's just a long title, so I just decided to say Worldchain and the OPStack. But yeah, the Superchain is a core part of the Optimism ecosystem. And so what it means is a network of L2s running the OPStack. That is essentially what the Superchain is. The reason why we call it a Superchain and not just a network of L2s running the OPStack is that they're interoperable within one another. As I mentioned before, there's this interoperability standard that is being worked on, and so that every single network that uses the OPStack in this specific way with the same configuration is able to feel like one network. This is essentially the gist of it, right? Like we have multiple OPStack networks running the same tech stack. We want them to feel like one, hence the Superchain, right? And there's a set of standards and set of technologies that we need to share in order for such a thing to be possible, right? So there's different kinds of scalability you can do. You can do vertical scalability by like deploying an L2 and then maybe like an L3, a scalability solution on top of the L2 that settles to the L2, and then that L2 scales to the L1, right? So this is vertical, it's up and down, right? Like L1, L2, L3, whatever. Then there's horizontal, right? So you can deploy multiple L2s on the same L1, and this is horizontal scalability. However, when you scale horizontally, you're fracturing a lot of the state, because now these networks are no longer aware of each other. So what the Superchain is trying to do is to break this paradigm where you have horizontal scalability and fractured state by having horizontal scalability but unified state through interoperability. So you can build an app on any OPStack network, and any other OPStack network that is part of the Superchain can use that app seamlessly without having to bridge in complex ways or be aware of a lot of third-party bridging mechanisms and whatnot, a lot of complexity there. So this is what the Superchain is. What does it have? It has a shared group of decentralized governance. So different Superchain members can vote on different proposals to change the Superchain, like change the OPStack, change different parameters, change different security mechanisms and parameters, do upgrades jointly for the Superchain. There is partial revenue share. So any Superchain network, in order to join the Superchain, you have to pledge to this law of chains that I also have over here, for any of those who are curious. Oops, I just wanted to open this link so that I can send it over here. We don't have much. Oops, I sent the same link twice. Give me 1 second. It just didn't copy through. This one. So if you use this link, you're able to read what the law of chains is. Essentially, it's a common shared set of values that people abide by when operating an OPStack network, so that you can be part of the superchain. And one of the clauses is that you share part of your revenue or profits with the Optimism ecosystem, so that people that are using the OPStack can benefit the general ecosystem of the superchain, right? So anything that any of the members sort of build, they can contribute back, so that it can contribute back to everybody else, right? Essentially, it's a way of funding this public good that is OPStack, because it's a public good. Nobody is paying anyone for doing this other than the Optimism Foundation through its treasury, and then Superchain networks that are sort of funding back something that they're using for free, really. So this is sort of like the benefit. You have shared security, shared decentralization. You have like shared upgrades, shared governance, all these things. But it's good to sort of contribute back, so that this technology is sustainable and economically sustainable, right? So it's funded well. And so Worldchain is going to be part of the superchain. I mean, like, we're already part of it, but it's not live. So let's say it will be part of the superchain alongside other networks like Base, Mode, Lisk, Fractal, and a bunch of others. You can just Google Superchain list, and it will just bring you this first link. I'm just, for the sake of time, I'm going to try and move quickly towards the end. So Worldchain, right? I've been talking a lot about what the OPStack is, what the Superchain is, what the technology behind it is, what the future for it is. But what is sort of the future for us as it concerns things like the Superchain or the OPStack, right? Like, what are our own priorities at WorldCoin for these things? So the first one is to essentially get Worldchain to Mainnet, right? Essentially, like you've mentioned, you had a few questions like, oh, when Worldchain, whatever. This is the thing that we're mostly focused about, mainly focused on right now. So essentially closing off the developer preview time and doing a mainnet launch. So I'm not able to share when that is going to be, but essentially as soon as we're able to do that, there's going to be an announcement, and you're going to be able to see things for yourself. And also, if you're a World app user, you're going to like see the flow of like going onto the Worldchain and whatnot. So this is our biggest priority right now, mainnet launch, getting all the dependencies, third-party partnerships, all those sorts of good things, so that Worldchain feels like any other chain to you, where you're like expecting the things you should expect out of a chain when it comes to user experience, developer experience, third-party ecosystem apps, and whatnot. How do economic incentives work in a superchain environment to encourage participation? Great question. So since it's open source, since it's decentralized, since people can just use it and become part of the superchain very early on, you can contribute to something with third-party people that are really smart. Like, everyone is just working together on the same thing. That's sort of like the incentives are there from sort of a non-monetary perspective, right? Like, it's this Ethereum value aligned sort of thing, where it's like you're building a decentralized set of infrastructure that scales Ethereum in this case. So there's the value alignment there. When it comes to the economics, that's sort of things like the law of chains, where you're like paying for it with part of your revenue or profit. So for example, Base has pledged to paying 2.5% of their revenue or 15% of their profits, whichever is higher, to the Superchain, so that you're able to fund the development of the OPStack, so that it's not just funded by the Optimism Foundation treasury or OP tokens, essentially, so that all the networks that use the OPStack and are part of the Superchain fund the development of the OPStack in perpetuity because they're using it. So this is sort of like how we're trying to balance economic incentives. And there's this law of chains, which is a legal pledge that these teams are doing, including WorldCoin, so that we contribute back whatever like specific share of our profit or revenue back to the Superchain in order to be essentially contributing, right? So that it's economically sustainable, as you mentioned. One of our biggest priorities will be scale. The reason for that is that, as I mentioned in the previous slides, like if we go way back, right, like you see how many users we have, like millions and millions of users. These millions and millions of users do millions and millions of transactions. And there's only a finite limited set amount of transactions that you can do within a specific amount of time. So at one point, we were about 60% of optimism mainnet. And this essentially means that we were the biggest submitter of transactions, and there's literally no space on optimism left for us to submit transactions more or scale, right? Like have more users than 10 million. Like 20 million users would have been impossible at this time because we just took too much of optimism, hence Worldchain, hence scaling, right? You're able to actually onboard 1 billion users to Worldcoin, which is the fundamental goal of the project, right? So this is why it's directly in our interest to scale OPStack, right? Like we need to support and onboard 1 billion users. Hence, we need to solve all these hard problems like scaling the EVM and scaling L2s and doing all this research and engineering to bring this to life. So another priority for us is scaling Ref and the required infrastructure to 1 GigaGas per second or 1 billion gas per second. Ref is this execution client written in Rust. This is like something I mentioned before with Rustifying the Superchain or Rustifying the OPStack. So Ref is this execution client built by Paradigm. Like I mentioned the article that I sent in the chat. So that one is just about like scaling Ref to 1 gigagas per second. That's like one of the things that we care about fundamentally. And developing the Rust Ethereum infrastructure. A lot of it was built by Paradigm, but a lot of it is also built by other people. So we want to contribute to those efforts to Rustify not only Ethereum, but also OPStack as a whole, like doing like a fault-proof program in Rust, doing a derivation pipeline in Rust, doing like all of these optimism components that I mentioned before that are open source, writing them in Rust. It's like an important thing because we care about the features that Rust brings. For those who are curious, it's things like memory safety. We're not able to access or dereference a null pointer and things like that. In Rust, that doesn't exist. On other programming languages like C or C++, there's a big problem. Rust is very performant. It's a compiled language. It's a statically analyzed language, so you can analyze it at compile time. It's not interpreted. And it's really performant, fast, compiles to a lot of different targets, uses LLVM. It's a lot of technical things for a lot of, maybe if you're not technical, it doesn't mean anything to you, but to us, it means a lot. And then there is account abstraction as a first-class citizen, right? So account abstraction is maybe tangential to the superchain, but an important part nonetheless. It's essentially this thing that allows you to treat a smart account as if you're able to do lots of different things. Because currently, like, you can only pay for gas within a smart account in the native token of the L2, right? So or the blockchain. So for example, if the native token of Ethereum is ETH, you can only pay for transactions in ETH. Account abstraction allows smart contract wallets to pay for transactions, for example, in USDC or Worldcoin or anything else, really, any token. And another thing that allows you to do is to subsidize gas for people. So you don't have to pay gas, but somebody else can pay gas for you. So for example, we could subsidize directly natively through account abstraction. There's other better things like recovery or like signing with passkeys. There's a lot of different changes, but this is like one of the main ones that we care about. If you want to learn more, I think we're running out of time, so I'm not able to explain what account abstraction is in detail, but I just recommend just like searching probably something like Alchemy, what is account abstraction? So if you search this, you should find an article from Alchemy, which is actually our partner for Worldchain. So we are not running Worldchain ourselves. We're partnered together with Alchemy, which is has a lot of different Ethereum tooling and infrastructure, including a Rollups as a service provider. So they're going to be running Worldchain together with us and partnering on the infrastructure side to provide the infrastructure to run Worldchain within Alchemy. So they're a good team that has a lot of educational resources. Highly recommend those. Are really great for beginners and people who are looking to learn more. Cool. Yeah, so that is everything that I had for these sets of slides. Again, I'm happy to go deeper into any of these topics in the future one, but maybe I can also answer the last few questions. I see one question over here. Okay, that's the same one. Cool, awesome. Sorry, I always get like towards the end, I start rambling quite fast because I want to meet the deadline.
No worries. I'm sure that was really helpful for everyone, even if you did rapid fire through the last few slides.
Yeah.
Now I'm talking too fast.
Yeah.
Thank you very much, dcbuilder, for coming in again and giving this workshop on Worldchain and the OPStack. We've got one more in the series, and that is on the future of Worldcoin technology. So I'm sure you're all going to join us again on Wednesday for that one. One last time in the Encode Club Worldcoin Educate Series. Other than that, unless anyone else has questions, there's a few people typing. Nope, just all thanks in the chat.
I see one question I didn't answer in the questions tab by Rainy at 6:46 p.m. something.
Yeah, sure, go ahead.
We have been getting airdrops since August. The first one was 6.18 WD, September 6. How many are there in October? How is this calculated on a monthly basis? Blah, 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 yada, yada. Okay. TLDR is that the WorldCoin team sort of has a grant contract, and this grant contract currently is set to a monthly frequency. So the monthly, so the grants like within World App are monthly. As it comes to the specific amount, I'm not able to say how that mechanism works. Not because I don't want to, it's mostly because I'm not working on that specific part of the team. And so don't have the detail. But essentially, my awareness is like there's an economics team that is able to sort of measure a sort of log curve of like as long as like the more people join the network, the rewards diminish over time. So yeah, it's mostly like an incentive mechanism to join the network, right? And so it's calculated based on an economics curve for predicting like what is the optimal sort of amount. As it comes to like a specific answer for why it changed from one month to another, I'm not able to say, mostly because I just don't know.
Thank you for covering that question. We've got lots of thanks in the chat for you. But we have come to the end of the session, so we will see everyone on Wednesday for the final workshop. And I hope you all have a good rest of your day.
Awesome.
Thanks, everyone.
Bye-bye.